Welcome to Module 8, Lesson 2. Our I can statement is, I can estimate products using a variety of methods and predict how the estimated product will relate to the actual product. So we've been estimating products for a while, right? Using estimation to assess reasonableness in our multiplication equations. The new thing that we're going to be doing in this lesson is predicting how that estimated product will relate to the actual product. So when we estimate, we know that that's not the exact answer. Sometimes it's less, sometimes it's more. We're going to be able to, in this lesson, determine how it relates. Is it more? Is it less? Is it closer to those sorts of things? So that's the new thing we're going to be working on in this lesson. Right. Mr. Adkins challenges his students to spend 45 minutes without electronics on each school day in November. For about how many minutes will each student be electronics free in November? All right, so we need to use front-end estimation to estimate the product. Letter A asks us, in what place value is the front digit in each number? Okay, so the front digit, the first digit, the greatest digit, is in the tens place. All right, it asks us to circle the tens, then write the estimated factors by changing all other digits to 0. So we're just thinking about the number of tens. So 19 has 1 10, 45 has 4 tens. We need to find the product of 10 times 40. These are estimated factors, which is equal to 400. 10 times 4 is 40. So 10 times 4 tens is 40 tens, or 400. Now we're going to use rounding to estimate the same product. So we're still doing 19 times 45. If I round each of these to the nearest 10, right? 19, I'm going between 10 and 20 are my nearest tens, and 40 and 50. Both of these are at or above their midway point to the next 10. So both of these are closer to the higher 10. So 19 rounds to 20 and 45 rounds to 50. So we need to find the product of 20 times 50. 2 times 50 is 100. So 2 tens times 50 is 100 tens, or 1,000. We had 2 very different estimates, didn't we? Our first estimate is 400. Our second estimate is 1,000. So now we need to assess the reasonableness. If we compare the estimates, which estimate do you think is more reasonable? The estimate of 400 or the estimate of 1,000? Well, let's think about the difference between these numbers. Our numbers are 19 and 45. Those are our original factors. In the front-end estimation, both of these numbers decreased, right? This went down by 9, and this was 5 less. When we rounded, both factors increased. This went up by only 1, and this went up by 5. So which of our estimated factors was closer to the actual factors? When we rounded up, these numbers were closer to the original factors, right? When we did 45, it's going 5 in each way, right? So both of those are pretty close estimates. But if you look at the difference with 19, 10 is 9 less than 19, whereas 20 is only 1 more. So we know if we're only rounding by 1, our factor is only increasing 1, that estimate is going to be pretty close. So which estimate is more reasonable? The rounded estimate. Is more reasonable. Right? And your why. Why? Because 19 is closer to 20 than it is to 10. Okay, so we're looking for why is it reasonable. So then we need to determine each student will be electronics free for about, and we picked 1,000 as our more reasonable estimate. So for about 1,000 minutes. All right, so let's take a look now at our next equation. Mr. Adkins' students make 8 origami animals. There are 27 students in his class. How can you use compatible numbers to estimate the number of origami animals the students make? Let's check our vocabulary. Compatible numbers are numbers that are easy to compute mentally. So we need to pick numbers that are close to these two numbers here, our factors, that we can use as a simple fact, ones that we can multiply in our head. Right away, I think of 8, and 8 is pretty close to 10. Now 27, I can think about a couple of different things, right? I could use rounding. It's going to be close to 30. Another compatible number is a number like 25. Because when I use 25, I can think about quarters, and it's just a nice number for me to be able to compute. So for the purpose of this problem, 30 is 3 more than 27. 25 is only 2 less. So 25 is going to be a closer number. So we're going to go ahead and use 25. All right, so we need to find the product of 25 times 10. 25 tens is equal to 250. So how many origami animals will the students make? They will make about 250. All right, and now here is where we're doing our new step. How will this estimate compare with the actual product? Because we changed both factors in this, it might seem a little tricky to figure out how does it compare with the actual product. So we have our two factors that we changed, right? 27 and 8. In 27, we chose the compatible number of 25, which is a little bit less than 27. We have the factor 8, which we rounded to 10. If you think about the jump between 27 to 25 and 8 to 10, while they both are only 2, right? We go 2 less to get there and 2 more to get to 10. 27 and 25 and 8 and 10, this is a larger number that we're multiplying by than this. When we rounded 8 to 10, our end product, is going to be greater than the product that we started with. So for letter D, how does this estimate compare with the actual product? This estimate is going to be greater than the actual product because this factor 8 was rounded to 10. All right, please go ahead and check, complete check understanding and press play when you are ready to check your work. All right, let's go ahead and check. So for front end estimation, we got 30 times 20 is 600. For rounding, 37 rounds to 40, 24 rounds to 20. And for compatible numbers, they chose 40 and 25. Which method would be the most reasonable if you want to make sure you had 37 craft materials for each student? I would use compatible numbers because it's the highest estimate. If I'm going to use this number to go out and buy materials, I want to make sure I have enough and I'm not estimating too low.